Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying quadratic lecture 2. In this lecture we'll be talking about sign of quadratic expression and we'll solve certain problems around that. So let us begin our lecture with the vertex of a parabola and consider that we have ax square plus bx plus c as a regular quadratic expression. We usually plot the graph of quadratic expression like this one. Although this is a very specific case where a is greater than 0, that's why this is facing upwards. But we usually plot this kind of graph, right? Now, what is the vertex of parabola here? Vertex is the lowest point in such a graph. In the reverse case, vertex would be the highest point. So the main thing is this particular point is called as the vertex, regardless if it's facing upwards or downwards. In the case of it's facing downwards, this point would be called as a vertex. Now there are certain important properties associated with this vertex point, right? So the first point is obviously it's the lowest point in case a is greater than 0. That means parabola is facing upwards. In that case, this point is the lowest point. So lowest or highest, you can say, point. Now second point would be, if let's say this root is alpha and this root is beta for this quadratic expression, in that case this point would be exactly at alpha plus beta by 2. So this is at the center, right? So this comes out to be alpha plus beta by 2, the x coordinate. Okay, so these are the two important properties of this particular point. Now in terms of coefficients, what this point would be? So this point would come out to be minus b by 2a. You can find out this value by adding the roots and dividing by 2. So the first root would be minus b plus root d by 2a. Second root would be minus b minus root d by 2a. If you add both of them, you'll get minus b by a, but you have to divide by 2 as well. So that would give us minus b by 2a. So this point comes out to be minus b by 2a. And according to that, you can also find out the value of the entire expression. Let's say this fx is the entire expression. If you plug in this value over here, you'll get the value of entire expression. Let's calculate that as well. So if I plug in minus b by 2a over here, we'll be getting a times b square by 4a square plus b times minus b by 2a plus c, right? So this becomes ab square by, sorry, this a gets cancelled here, so it becomes b square by 4a. This becomes minus b square by 2a plus c, right? Now if I multiply and divide by 2 over here, I'll be getting minus b square by 4a plus c. If I further simplify this, I'll be getting minus b square plus 4ac divided by 4a. So if I further simplify it, I'll be getting minus times d divided by 4a. So this becomes minus d by 4a, where d is the discriminant. So the value over here is minus b by 2a, the x coordinate. The y coordinate would be minus d by 4a, where d is the discriminant. Okay. Now let us talk about signs of quadratic expression. So until now we only studied ax square plus bx plus c equals to 0. So this was the only thing which we studied. But now it's time to study greater than 0 or less than 0. Right? Let's see how that works. So the first case we have is the usual case. This parabola, the very standard one, right? In this case, the equation is ax square plus bx plus c, but here are certain restrictions. In this case, since parabola is facing upwards, for that a is always positive. In case a is always positive, parabola would be facing upwards. Now we can see that the parabola is cutting x-axis at 2 points. That means we have alpha and beta as two distinct roots over here. Since it is cutting x-axis at 2 points, we have two distinct roots. When we have two distinct roots, that means discriminant is greater than 0. So that is the second condition, right? So these are the two important conditions for this particular case. Now in this case, we have both signs possible. So for a particular value of x over here, let's say this is x1. For this particular x1 value, this expression would take value somewhere over here, right? That means it is taking positive value for some x1. Also, if I take some x2 over here, it is also taking some negative value, right? So this kind of parabola would take both positive, negative values. It takes both positive or negative values, considering that we are taking x1 and x2 respectively, right? Now we have the second case, that is the exact opposite of this one. So that would be this case. In this case, a is less than 0. That is the first condition. In the previous case, we had a greater than 0, but in this case, a is less than 0. So whenever a is less than 0, this parabola faces downwards, right? Second condition is, again we have alpha and beta as two distinct roots, so d is greater than 0. And third case, it also takes positive or negative values, because some values are over here, some values are over here, so it takes both positive or negative values, right? Now let us talk about the third case. In third case, we have a parabola of this sort. Now the first condition should be obvious, that a should be greater than 0, right? Because this is facing upwards. But in this case, it's not touching x-axis at any point. So we can say that there is no real root over here, because it's not cutting x-axis at any point. So there is no real root. When there is no real root, we can say that d is less than 0. And it's always positive. See, it's always above x-axis. So for any value, you can take this value, or this value, it's always going to be positive. Always positive. Always. So first point, second point, third point. So the main condition for a quadratic expression to be positive, always positive, is when d is less than 0 and when a is greater than 0. When these two conditions are satisfying, the quadratic expression will always be positive. Now again we have the exact opposite case. We have a parabola of this sort. Now we can see that it's not touching this x-axis over here. So since it's facing downwards, a is less than 0, but d is also less than 0, because we don't have any kind of real roots over here. It's not touching, it's not cutting x-axis, not even touching, right? Now in this case, it's going to be always negative. So first point, second point, third point. When a is less than 0 and d is less than 0, it's always going to be negative. In case we have just given that d is less than 0, that means either the function is always positive or always negative. Unless we don't know the sign of a, we cannot conclude on the direction of parabola, right? Now we have the fifth case as this one, where it's touching at one single point. Now in this case, since this is facing upwards, we can simply say that a is positive, right? But since this is touching at just one single point, so it has just one root. That means it has two equal roots. D should be equals to 0 over here, right? And in this case, it's always going to be either positive or 0. This value expression, the fx would always be greater than equals to 0. Either it's always positive or equals to 0 in just one single case, right? Now the last case, the obvious one, we have a parabola facing downwards but touching at one single point. In this case, a is less than 0 because it's facing downwards, d equals to 0 because it's touching just one single point. That means we have two equal roots, and the value of expression is less than equals to 0 because it's always negative, or it is 0 in the worst case for this particular point, right? Now let's solve this question. For all x, x square plus 2ax plus 10 minus 3a greater than 0, then the interval in which a lies is. Now the important point over is positive and for all x, right? Now for this quadratic expression to be always positive, we have two conditions. So in case we have ax square plus bx plus c as the quadratic expression, for this to be always positive for all x, it should have a as positive and d should be less than 0, right? So a is what? A is coefficient of x square. Over here we have 1 as the coefficient of x square. So this condition is satisfied already, right? We have to satisfy this condition, that is d less than 0. So over here d is 4a square minus 4 times 10 minus 3a, right? This should be less than 0. So this 4 gets cancelled out. We are left with a square minus 10 plus 3a less than 0. So this becomes a plus 5, sorry, a plus 5 multiplied by a minus 2 less than 0. So a belongs to minus 5 to 2, right? So B seems the correct answer. Now let us solve this question. Find all values of a for which the inequality a minus 4x square minus 2ax plus 2a minus 6 is less than 0. Right? So remember that we studied for ax square plus bx plus c to be less than 0, a should be less than 0 and d should be less than 0. The coefficient of x square should be negative and discriminant should be negative. And when both these conditions are satisfied, we can say that the quadratic expression is always less than 0, right? In this case, coefficient of x square is a minus 4, so a minus 4 should be less than 0. That means a should be less than 4. So that is the first condition. Second condition would be d less than 0, right? So d is 4a square minus 4 times a minus 4 multiplied by 2a minus 6 should be less than 0. So if I expand it, I'll be getting 2a square minus 6a minus 8a plus 24 less than 0, right? Now this one is cancelled out. Now we are left with a square minus 2a square, that is minus a square. We have minus 6a minus 8a, that means minus 14a, and with a negative sign, so we have plus 14a, and we have 24 with a negative sign, minus 24 less than 0. So what we can do, we can write this as a square minus 14a plus 24 should be greater than 0, right? Now that means a minus 12 and a minus 2 should be greater than 0, right? So this becomes a belongs to minus infinity to 2 union 12 to infinity. So this is the final condition. Okay. Now let's solve this example. If ax square plus bx plus 10 equals to 0 does not have real roots, find the minimum value of 5a minus b, right? So the main condition over here is it does not have real roots. That means d is less than 0, right? But we still cannot comment on the direction of parabola, if it is facing upwards or downwards, because we don't know what kind of values a is taking, right? So it might be possible that this parabola is facing upwards or it's facing downwards. Let's try to find out which direction it's facing for, right? Now the quadratic expression over here is ax square plus bx plus 10, right? Now, if you put x equals to 0 over here, we'll be getting 0 plus 0 plus 10, which is positive. Now, there cannot be a case where parabola is facing downwards and d is less than 0 and still we are getting some positive value. It cannot be the case, right? Because it doesn't even touch the x-axis. It doesn't even touch the 0 value over here. So that means it has to be the parabola of this sort, something of this sort. D is less than 0, so there is no real root and it's always positive. That's why we have got a value f of 0 as positive, right? Now once we know that, I have to figure out a way where I can find out the value of 5a minus b. I can see 5a over here, I can see 10 over here. So let's put f of 5 over here. Okay, for f of 5 we'll be getting 25a plus 5b plus 10, and we know that this should always be positive, right? Because the parabola is facing upwards and d is less than 0, right? So in this case we'll be getting 5a plus b plus 2 greater than 0. But this doesn't match our expression. So let's try to put f of minus 5 over here. We'll be getting 25a minus 5b plus 10 greater than 0, right? Now this would give us 5a minus b plus 2 greater than 0. That would give me 5a minus b always greater than minus 2. So the minimum value would be something very smaller, bigger than minus 2, right? In case there was an equality, we would have said that, okay, my minimum value is minus 2. But in this case, let's say find the minimum integral value of 5a minus b, that would be minus 1. So minus 1 is just bigger than minus 2 as an integral value, right? So now with all these examples, we have got a fair idea of different signs of quadratic expressions. So in next lecture, we'll be moving forward with location of roots. That is one of the most toughest part of quadratic equations, right? So that lecture will be a little lengthier with more number of examples. Okay. So let's meet in the next lecture. Thanks for watching.